Now we have a new chart. We're going to learn how to use the method of partial fraction to solve inverse Laplace transform of a rational function. Okay, so let's do an example. So suppose we want to find the inverse Laplace transform of this fraction x squared plus 1 over s cubed minus 2s squared minus as. So first, we try to factor the denominator. So this is equal to s times s squared minus 2s minus 8, which is equal to s times s plus 2 times s minus 4. Now, the method of partial fraction tells you that the original fraction is equal to a over the first factor plus b over the second factor plus c over the third factor. To solve this, we multiply by the common denominator, which is the product of the three factors. So we get s squared plus 1 equals to a times the other two factor plus b times the other two factor plus c times the other two factor. To find the values of a, b, and c, we have tricks. We can plug in the roots. So if we plug in s equals 0, we get 1 equals to negative a, which implies that a is negative 1/8. If we plug in s equal to negative 2, then we get 5 equals to 12b. So b is 5 over 12. And if we plug in s equal to 4, then we get 17 is equal to 24c. So we get c is 17 over 24. So this tells you that the original fraction is equal to negative 1/8, that's a, times 1 over s, plus 5 over 12, that's b, times 1 over s plus 2, plus 17 over 24, that's c, times 1 over s minus 4. So if we want to find the inverse Laplace transform of the original fraction, then it's the inverse Laplace transform of the three terms. And because it's linear, so the coefficient stays. Now, the inverse Laplace transform of 1 over s is just 1, or technically s to the 0th power. And then the inverse Laplace transform of 1 over s plus 2 can be found using this. So it's going, a is equal to negative 2, so this is equal to e to the negative 2t. And for the third one, 1 over s minus 4, in that case, a is equal to 4, and n is equal to 0 for both cases. So this is equal to e to the 4t, I meant. All right, so let's do a different example. Let's move the chart to the right so we can save time. So let's do a different example here. Suppose we want to find the inverse Laplace transform of, let's say, s squared minus 1 over s1 minus 1 cubed. Okay, let's change the numerator to, because this factors, let's change it to s squared minus 3. Okay. So the denominator is already a factor for you, so we don't have to deal with that. The partial fraction method tells you that the original fraction is equal to a over s minus 1 plus b over s minus 1 squared plus c over s minus 1 cubed. So if we multiply by the common denominator, s minus 1 cubed, then we get s squared minus 3 equals to a times s minus 1 squared plus b times s minus 1 plus c. So we can still do the trick at least once. We can plug in s equal to 1, so we get negative 2 equals to 0 plus 0 plus c. So c is negative 2. But To find out the values of a and b, we need to use some tricks. So we take this equation, we take the derivative on both sides. So we get 2s equals to 2a times s minus 1 plus b. And if we plug in s minus 1 into the derivative, then we get 2 equals to b. And we can take the derivative again. And we get 2 is equal to 2a. B disappears, and we don't even have to plug in s equal to 1 here. We get a is equal to 1. So that means the original fraction is equal to 1 over s minus 1 plus 2 times 1 over s minus 1 squared plus, minus 2 times 1 over s minus 1 cubed. So the inverse Laplace transform of the original fraction is the sum of the inverse Laplace transforms of all the three terms. For all three terms, the value, we look at the chart, same entry again, a is equal to 1 for all three of them. For the first term, n is equal to 0. For the second term, n is equal to 1. For the third term, n is equal to 2. So the inverse Laplace transform is equal to, this is e to the t plus 2 stays coefficient. This is e to the t times t to the first power, and minus 2 times e to the t times t squared. So this is our final answer.